Okay, so this is 3-1 functions. So the first part, it gives us a long definition. Don't write that because it sounds super confusing. So it says a relation pairs inputs with outputs. When a relation is given as ordered pairs, the x coordinates are inputs, the y coordinates are outputs. A relation that pairs each input with exactly one output is a function. Did that make any sense? No, it sounds super confusing. So whenever it's talking about a function, this is mainly just talking about each input can only have one output. So you might somewhere on your notes put that x is your input, y is your output.
I don't write that.
Wait, what is this? It's 3-1?
Yes. Okay, so what that means, they give us 4 different types of examples here, A, B, C, and D, and we're just determining if it's a function. So right now we're just answering yes and no. So what you look for is your input values, because those are the numbers being plugged in. Your output values are not as important for this. So when we look at our input values, our x, you can't have the same thing more than once. You can't have any repeating for your x values. So looking at A, maybe, is it going to go up anymore? Of course not. It went up all ago. Huh.
Wow.
Yeah, that was just to make it start recording. Oh well, you're just not going to be able to see it.
I can just say
okay, it's fine. A says -2, -1, 0, 1, and 2. You're only looking at the x values. Are any of those repeating on A?
There's 2? Oh, the x values?
-2, -1, 0, 1, and 2. Are any of those repeating? No. So since they're not repeating, sorry, I didn't mean to even write that, then that is a function. Because that just means each input value has one output. It's not repeating. So then on B, we have 4, 8, 6, 4, and 5. I don't know why that won't raise up now. Whatever. Is B a function?
No.
Why?
Because there's 4s or 4s.
There's 2 4s in the x value, so that is not a function. Okay, you don't have to write all these down. On C, we have -2, -1, 0, 0, 1, and 2. Is that a function?
No.
No. Why?
Multiple zeros.
2 zeros in the x value.
Oh, yeah.
And if it was a function, it still would be a function
Yeah.
because rule and whatnot.
Okay, so it is not a function because of the 2 zeros, your 2 input values. So then looking at D, you don't have to draw this one, I just am, because then I'm going to show you another example of it. These are input, these are output. So far, would that be a function?
Yeah.
Yes, because each one of these only has one line coming from it. So then, say I were to switch that same problem to this. Is this a function? No, it's not, because we have 2 coming from the x values. These are just points. This is like saying that's the point -1, 4, 3, 15, and 11, 15. Well, this is saying the points -1, 4,
Oh, it'll be 11 twice.
11, 3, and 11, 15.
Wait. I just realized how I get a dentist appointment
there's 2
after
lines.
school.
Okay, so this one is a function. Don't forget I'm recording, Jonathan.
Oh.
This one is not. Okay, since we have 2 11s. So far, so good. Okay, what we're going to look at next is called the vertical line test. Oh, actually, just kidding. I'm going to have you try all 4 of these. Forgot. Try all 4 of those problems. Okay, I want you to try all 4 of these problems, and then we will go over them together. You're determining whether the relation is a function, and then just tell me why or why not. Okay, example 1. We have the points negative 5, 0, 0, 0, 5, 0, 5, 10. Is that a function?
No,
Why?
because the zeros, there are multiple 5s in these.
Okay, so you could just tell me there's 2 5s, or your input, there's more than one input that's the same. Any of those work, that's fine. So number 1 is no. Number 2, I have the points negative 4, 8, negative 1, 2. Sorry, 2, negative 4, and 5, negative 10.
Yes.
Yes, that one is a function.
There are no.
Each input value has exactly one output value. 3, we have a table. Is that a function?
Yes.
Yes, they're all different. And 4,
No.
No.
no. All 3 of them have 1/2 as their x value.
Because, no.
So you would just say no because they're all the same input value. They all have 1/2. Okay, so now we're going to look at what's called a vertical line test. So, how this works. What does vertical look like?
Diagonal. Oh wait, vertical.
That's a diagonal. Vertical is straight up and down. So what you can do is you can use your pencil or your pen to help you on these. So vertical line test, I'm going to draw that first one just to help explain it a little bit better. Ugh, that sounds awful. Okay, so when you're looking at a graph and you were talking about vertical line test, there's no lines on this one, it just has points. So you take your pencil, okay, straight up and down, and if you are to lay it on your paper and it passes through more than one point, it is not a function. So for example, if you look up here, if I put my marker right here anyways, does that only pass through one point
No.
so far? Yeah.
Yes.
If I draw this all the way up, that only passes through one point so far, right? Okay, but if I move it right here, does it pass through 1 or 2?
2.
So that is not a function. It can only pass through 1, and you can check all the way across. If this had been where they were all in between, then it would have been a function. But since we had 2 that are in the same line, when we do the vertical line test, it is not a function. Because if you actually look at the graph, what that means is that you would have 2 of the same x. So that is not a function. But then if we look at the next one, and I'm not even going to draw it exact like that because it doesn't matter. Does it pass right here? The vertical line test anyway. Yes? So is this a function?
Yes.
Yeah. So if you have a straight line across, yes, it's a function. So all the vertical line test means is you can draw a vertical line and check to see if it's a function. Just like in those 2 examples at the very top even. Even though it's like a sideways looking, that's called a parabola, it would touch in 2 spots, so that's not a function.
Kind of looks like a boomerang.
Okay, so you are going to do these next 4 problems. Let me turn the video. Okay, so you're going to try all 4 of these using the vertical line test. You can just use your pencil or your finger. Copy down the graphs. You don't have to write these numbers. Just kind of jot a basic graph down so that you have what it is. And you're just telling me yes or no. Okay, the first one. If we do our vertical line test, is that a function?
Yes.
Yes. Okay, on what is it, 6? On 6, is this a function? Yes, it is. Doesn't have to be a straight line to be a function. That just means it's linear if it's a straight line. So that little side note is actually called a parabola. If it's up and down like that, that means it has an x squared in the equation somewhere.
Cool.
Ta-da! If it does this, that means it has an x cubed. And if it does this, that's an x to the 4th power.
Wait, X4? We
Because they none of them
can't
pass
do that,
this.
Dad. That's too scary.
Anyway, you'll learn about that in high school. Okay, number 7.
No.
No.
Because the bottom is.
Because it would pass through 2. So, no. And this one?
Yes.
Yes. So only one of them was not a function.
Next was a circle.
And that was a circle.
This circle. Okay, so next we're going to look at what's called domain and range. Y'all have seen this before. Hold on. So on example 3, we're looking at domain and range. You might go back to your little note about x and y. Domain is also your x. Y is your range. It just means like your domain values, everything that x can be, range is everything y can be. So on A and B, on A, if you notice, we don't have a line, we just have points. I know y'all maybe can't see what those are, so I'll write down the values of those points. So we have -3, -2. That's one of those points. You can write the points down. -1, 0. 1, 2. And then that last point is 3, 4. So write those down. What it means by domain and range is go back and tell me those values. But if we have any that are repeating, you don't write them more than once. So my domain, I have -3, -1, 1, and 3. My range, and you can just put D and R. We have -2, 0, 2, and 4. Your domain and range values. Does that make sense so far?
Sure.
I need you to be able to understand this one before the next one we look at. So if you don't understand it, let me know. All I've done is I've gone back and listed my x values for domain, and I've listed my y values for range. Because it was only points. Okay, it wasn't a line or anything, it was just points on there.
I do have a question though.
Yes.
How can you tell which one's which?
What do you mean? How can I tell what the point is?
Yes.
By reading the graph. I know it's hard for you to see from back there, but by reading the graph on where it is. Well, they told me right there is -2, so that means this is -1, -2, -3. So I knew it was -3, down 2 was -2. So that was the point, -3, -2.
I just didn't really know exactly because the dots, I just didn't know.
Did that help though, what I just showed you?
Yeah, it helped. I
Okay.
was like, how could you tell if something was something?
Yeah, they counted by 2s, but they just wrote the 2s. This is still -1, -2, -3.
I mean, I can see that. I was just wondering, like, how can you tell by just looking at one of the dots, for example, the one on the top right, for example, like, oh, that's domain, or that, oh, that's range.
Because X is in front.
Oh, every point has a domain and a range. It's not one or the other. Your X value is always your domain, your Y value is your range. Every point is always set up X, then Y.
Like the first, remember
So
the
that,
parentheses?
so the top right, for example, is 3, 4.
Yes.
Okay, I understand now. I was just trying to make
Okay.
sure.
All right. Okay, so when they are just points that are given to you, you just list your domain and range. Okay? When it's a line, like this next one, let me just kind of casually redraw this. Y'all don't draw that. So I can do it for the, let's see, -2, -1. Why did I draw my graph like that? What it goes up to. Okay, so it is a continuous line. It looks like this. So what we do for this, your domain, so this is your X axis, correct? The horizontal one? Yes. And this one is your Y. So to find your domain, we know that's our X. Actually, you don't even do that. So you only look at the X axis right now. Looking only at the X axis, how far does it go to the left?
Like 2. Oh, 3. What are you talking about?
I'm talking about the line on there.
Oh, what are you talking about?
Okay, on the x-axis only, how far does this go?
Oh, to, like, you want that?
Right now, I just want the number it goes to.
3?
To the left, I said.
2? Negative?
Negative 2. It goes all the way to negative 2. But we're only worried about the x-axis, okay? So it goes all the way to negative 2. So I have negative 2. How far does it go to the right?
Positive 3.
Positive 3. Okay, you're going to have an x between them. Now, what we're doing is we're making an inequality because it's from one to the other. So, we have a negative 2 is less than or equal to x is less than or equal to 3. Because if this had been on a number line, like what we've been doing, right? Okay, we're used to seeing it like that so far. Since it's shaded in between, that means it's what type? And, which means you can write one inequality. If I wrote this inequality, I have a negative 2 and a 3. How would you write it?
Close circle? Wait.
How would I write the inequality for this? It's what y'all's test was just over.
Like that way you just did up there.
Yeah. I was just wanting y'all to say it.
Oh.
Okay, so it works the same way. It's just it's not on a number line. Okay, so even though it looks all jagged, you're still just looking at it right now in terms as if it was graphed just on this line. So we have that x is between, basically, which is what these signs mean. It's bigger than negative 2, but smaller than 3. Okay, so and that means everything in between. So that would be your domain. Then for your range, you're still thinking about it like this, but now we're only going to look at the y-axis. Let me switch colors. That might help some. So for the domain, we just looked from here to here. On the range, we're looking at the y-axis. So I'm looking from here to here. Does that make sense? So you're only looking at this line, and we're trying to see how far it goes on that line. So looking at it like that, how low does it go on the y-axis? To negative 1. How high does it go? Positive 2. And it's everything in between. That is your range. So you kind of have to think about these mentally. You have to visualize just the x-axis for your domain, and then you have to visualize just the y-axis for your range. Okay, so I want you to state the domain and range of these two graphs. You can copy the graphs down so that you have them, and then tell me the domain and the range, and then we'll go over it. Okay, on number 9. List your points first, and it doesn't matter the order. So we have the point negative 2, 4, negative 1, 2, 0, 0, 1, 2, and 2, 4. Your domain is listing your x values. So we have what?
0, 1, 2.
Negative 2, negative 1, 0, 1, 2.
Oh, I forgot the other side.
For your range, though, you have 4, 2, and 0, and that's it. Why?
Because
Because it's the same numbers, 2 and 4, and I already have those. You only list everything once in your domain and range.
Good to know. Good to know.
Okay, is it 10? On number 10, since it is a continuous line, it's going to be an inequality. So look at them separately. So for your domain, only look at the x-axis, which means we're only worried about down here. Okay? Hold on, wait till everybody can watch. Here, y'all look up here for a second. For the domain, we're only worried about down here. Where does it go from just down here, looking at it?
Up to the 3. 1, 3, and 5? Or the 3?
Well, it's a continuous line. So it goes from 1 all the way to what?
3, 5.
All the way to 5.
Yeah.
It's a continuous line. So it goes from 1 to 5 on the x-axis. So your domain is going 1 to 5. All these tell you is that it's everything in between, or it could be. So it's from 1 all the way to 5 on the domain. So then the range, you're only looking at the y-axis. So if you were to like squish all of this up against the y-axis, what would it touch?
4.
4 all the way to?
0.
To 0. Yeah, down here is 0. So it goes from 4 all the way to 0. So I have 0 to 4 and everything in between.
Wow.
Does that make a little more sense seeing me do it for you?
Yes.
Still kind of confusing?
Wait, can you read that again?
Yeah.
That made a little more sense, yes.
Okay, the next thing we're going to talk about are independent and dependent variables. So, real quick, back to labeling again. They have so many names. X is your independent variable. You might write that down. Y is your dependent. So, X, independent, just like the song I-N-D-E-P-E-E-N-D-E-N-T. Do you know what that means? What does independent mean?
It means they can be
They can do it by themselves.
Yeah, they don't need nobody. They can do it themselves. Okay? That is what independent means. What does dependent
They
mean?
depend on you for water.
They do. Okay, yeah. Okay, yeah, that too. So just like legally you are all dependents because legally you have a guardian, someone is responsible for you. Legally, I'm independent, which means no one is my guardian who has to take care of me. I have to take care of myself. So what that means, it kind of means the same thing here. Since x's are independent variable, it means nothing affects x. It's a number we're given or it's its own entity. Y depends on what x is. So y can be changed or fluctuate depending on what x is. So x is your independent, I already scrolled it down, never mind. So it says the function y equals negative 3x plus 12 represents the amount of y of juice remaining in a bottle after you take X amount of gulps. Okay? So then they ask us two questions, A and B. A just says identify your independent and dependent variables. Well, we know X is independent, Y is dependent, but it means relating to that problem. So what were they talking about for Y in that problem?
The dependent variable?
No, I'm not asking dependent or independent. Yes, Y is dependent. But in this specific problem, what are they talking about for Y?
What represents the amount of Y?
The juice. Y is your juice remaining, okay? So then what is X?
The gulp.
The gulps. Okay, so that's all A means. You would say your independent variable is your gulps, because that's your X. Your dependent variable would be juice. That's all they're asking is if you can understand it in terms of the problem they're talking about.
Wow.
B, it says, excuse me, the domain is 0, 1, 2, 3, and 4. What is the range? So do you see how they already give you numbers for the domain? That means they're going to give us our X. So we could make a table. They said use 0, 1, 2, 3, and 4. And they said find your range. So this is just like that little machine we were talking about a while ago. X is what goes in. In the machine is your function or your rule that you have to work out. The answer you get out is your Y. Remember the little machine that kind of showed that? That's what we're doing here. We can do it in a table. When they give us domain values, they gave us our X. The function was Y equals negative 3X plus 12. So that is your rule. That's kind of like what would be in here. So I literally just take and plug those numbers in. So I'm going to rewrite this over and over again, but each time my x changes. What is 0 times negative 3?
0.
What's 0 plus 12?
12.
Do you see how y is just the answer you get out? So now we're just plugging in a table. Y'all have done these before.
Yeah.
So this line, I would have negative 3 times 1 plus 12. What is negative 3 times 1? So then negative 3 plus 12
Is positive.
No.
Positive 9.
9. Okay, and we would fill in the rest of the table, and then your answer is they just want your ranges. They just want your final answers. Does that make sense so far on these?
12, 9.
Yeah, these are easier.
Okay, so then we're just filling it in. Negative 3 times 2 is negative 6 plus 12 is 6. Negative 9 is 3. And then 12 plus 12 is 0. So your answers would be this. Do y'all see that?
Yeah.
They just want you to go back and list your range.
Is that it? Or is there...
Okay, so the last example we have to look at are these 4 up here, A, B, C, and D. It's going to be kind of confusing on A and B, but wait till we get through C and D and it'll start to make sense, okay? So first let me write them. So we have A is y equals 2x plus 5. B is y equals square root of 4x. Okay, so what we're having to do is determine whether they are a function or not. It says determine whether y is a function of x, and then state the domain. If you notice, we're not having to worry about range on these, just domain. Which one's your domain?
X.
X is your domain. So on this first one, A, how we first of all determine if an equation is a function is you're just going to have to plug some numbers in. So we know x is our independent variable, so I'm just going to plug in -1, 0, 1, 2. Okay, so if I plug these in for x, yes, ma'am. If I plug these in for x, I have -1 here. What's 2 times -1?
2 times -1 is -2.
And then -2 plus 5.
3.
3. So when I plug -1 in for x, these are the answers I get for y. 3. Okay, if I plug 0 in for x, what would I get for y?
5.
If I plug 1 in,
7.
7. And then last one, if I plug 2 in,
9.
9. So do you notice, are we getting a different number every time?
Yeah.
Yes. So all that tells me is that yes, it's a function because we get different numbers. We're not getting the same thing. It's not repeating. Okay? So it is a function. Did anything weird happen? It was pretty easy. You just plug in and get something. So that means your domain is all real numbers. Don't worry about really understanding that yet till we get to the next one. It'll make a little more sense. Okay, on B, we have y equals the square root of 4x. So again, I'm just going to use -1, 0, 1. If I plug -1 in here, 4 times -1 is what?
4 times
-4.
-4. Can I take the square root of a negative number?
No.
No, so I can't do that one right now. First, let's move on. If I plug 0 in, what's the square root of 0?
0.
It's just 0. What is, if I plug 1 in, that's 4. What's the square root of 4? 2. So if I keep going positive numbers, I'm going to keep getting numbers. It's when it's negatives that it doesn't work, right? So that means this is still a function because we're still getting different numbers every time. So it is still a function. It's just my domain cannot be negative numbers, right? Just because we cannot have a negative in there. So your domain would be x is greater than or equal to 0. Because that's where we first got a number. Anything below that, it gave me negative in there and we couldn't solve it. So it is a function. your domain, and you don't have to write domain like that, you could just do this. Your domain is x is greater than or equal to 0. Okay, now we're going to look at C and D. So if you notice, what does this one have that's different so far? Plus minus. Okay, so to recap what that means, let me write D down first. Okay, what that means, back whenever we did square root of 4, we know that's what? 2. Because we know 2 times 2 is 4. What about negative 2 times negative 2? It's still 4. So technically, when you're taking the square root, you have two answers. It's the positive and negative answer. It's just when we have square root, that just means we always want the positive answer. When they say this, plus minus, it means they want both options. So that would mean they would want 2 and negative 2. Okay, so if we come up here, we're going to do like we have been. We're just going to plug some numbers in for x. Negative 1 plus 3 is what? 2. Square root of 2 comes out to like 1 point something, so we'll leave that. Wait, hold on. So that would be 1 point something, but we have negative 1 and positive 1 is what I was getting at. My bad. 0. We would get 3. Square root of 3 is like 1.5 something, so we would have 1.5 and negative 1.5. And then 1. Let's do one that works out nicely. 1 plus 3 is what? 4. Plus minus square root of 4 is 2 and negative 2. Okay, so what this means, these are points, okay? So like right here, that would be the point 1, 2, and the point 1, negative 2. Is that a function?
No.
No, why? Because we have our x value being repeated. So basically, if it has like a plus minus, it's not a function. Now, we still have to go back and state the domain though. This one's kind of similar to the last one. We just can't take the square root of what? Of negatives. So what number would I have to plug in for x to make it negative in here? Or you think about to getting it equal to 0. What would you have to plug in for x to make that equal 0 in there?
Negative 6.
Negative 3. Negative 3 plus 3 is 0. So anything less than negative 3 would make it negative in here. So for your domain, its x has to be greater than or equal to negative 3. Because that's what would make it negative inside square root. Are y'all still with me so far? Sort of. I know these are kind of blurry. Weird. Okay, last one. I want to preface with something first. I know you've seen this before, but you can only have one of these. You can. This is 0 divided by 1, 1 divided by 0. Only one of these works, the other one does not work. I'm going to show you or tell you a trick to remember it. It's silly, but I promise it helps. You won't forget it. So, in the summertime, when boys go swimming, can they swim without a shirt on legally? Yes. Legally, can they swim without bottoms? No. So you can have 0 on top. 0 divided by 1 just equals 0. You cannot divide by 0. You cannot have 0 on bottom. Okay? Yes, sir?
Also, dividing by 0 kind of breaks the universe, so...
Yeah, it doesn't work. Don't do that. Okay? So I just wanted to kind of show you that because we have a fraction. So again, we can still just plug some numbers in to check to see if it's a function. And you can choose any numbers. I just like these because then I have a negative and a positive, and they're easy numbers. So if I plug negative 1 minus 2 is negative 3. So that really is just negative 1 over 3. If I plug 0 in, what do I get?
Negative 2.
So just negative 1 over 2. If I plug 1 in, 1 minus 2 is negative 1. So that would just be negative 1 because 1 over 1 is 1. Okay, so it is a function because we're getting different numbers each time. You're only worried about your x value to see if it's different numbers. So for the most part, they're mostly always going to be functions. Very rarely are they not. But now when we look at our domain, based on what we just talked about, the swimming thing, what can I not have?
The one on bottom.
I can't have a 0 on bottom, okay? So we have to make sure for our domain, what would make this equal to 0 on bottom?
-2.
Just 2, right? Like if I plugged 2 in, I would have 1 over 0, and we can't have that. So my domain is basically every number out there, all real numbers, except x cannot equal 2. Because it just can't be 0 on bottom. But if it's any other number, you get an answer. So your domain is all real numbers except x can equal 2. All I did was draw an equal sign with a line through it, which means cannot equal or does not equal. So does that kind of make a little more sense now that you've seen the last two? Okay. Okay, now I want you to try all 3 of these. You're determining whether it is a function and then state your domain. On 13, if we plug some numbers in, if I plug -1 in, what is -1 squared?
1.
Positive 1 plus 3 is 4. 0 squared
3.
is just 0 plus 3, yeah. And then 1, if you plug 1 in, what do you get? 4. So you're getting the same answer here, but do we have different values here? Yeah, even if I listed those as points, I don't have my x's repeating. So that is still a function. That would just be like if we graphed it. Remember yesterday, what did I tell you x squared would look like on a graph? I showed you x squared, x cubed, x to the 4th power. Do you remember? Okay, so x squared, like if I were to graph that, it would just be like this. I hear him. So if you did vertical line test, that's still a function, right? Yeah.
Is the boomerang function?
So that is still a function, okay? And no matter what I plug in, we get an answer. So your domain is what?
X is greater than or equal to 0? I don't know.
Okay, so if I plug a negative in there, can I do it?
Oh.
Yeah, there's nothing that I can't. And I'm not dividing by 0 or anything, so it's just all real numbers.
Wow.
Gotcha.
Wow.
Okay, on 14, since it's a fraction, we know we're going to have a stipulation. What can we not have with a fraction? A 0 on bottom. So we know that's going to mess with our domain. But other than that, let's go ahead and figure out if it could be a function. If I plug in -1, 2 plus -1 is just 1. 4 divided by 1 is 4. If you plug 0 in, you get 4 over 2, which is 2. If you plug 1 in, I'm just going to leave it at 4 divided by 3 for now. So is that a function?
Yes.
Yeah, it's a function. But we know the bottom cannot equal 0. Okay, so in your head, you're basically saying you're solving a little mini equation, 2 plus x equals 0, to see. So it would equal 0 when x is -2. So it cannot be -2. Can we have anything else? Or is there another stipulation? Or could it be any other number? Could I plug in any other number and it still work?
No.
Yeah, as long as we don't get 0 on bottom. So it only doesn't work for that one number. So your domain is all real numbers, but x cannot equal -2. Because -2 is what would make that 0. 2 plus -2.
And
that would cause you to be illegal swimming with no bottoms. So, on 15, last one, if we plug some numbers in, if I plug in -1, 4 plus -1 is 3. Square root of 3 is like 1.5-ish. If I plug 0 in, that's the square root of 4, which is 2. 1 is 5. Square root of 5 is 2 point something-ish. Okay, so is it a function?
Yes.
Yeah, it is. But what do we know about square root for domain? What can you not have? I'm not talking about a specific number. You can't have negatives, okay? You can't take the square root of a negative. So basically anything lower than 0. So what you're mentally doing is setting it equal to 0 to see what the minimum thing that it could be is. So I'm basically solving for x. So when x equals -4, it's 0 in here. We can have that, but can we have anything less than that? No, anything smaller than -4, and it would make it a negative in there, and we can't do that.
So it has to be x is greater than or equal to -4.
X is greater than or equal to -4. That would be your domain.